talk a bit about the stationary points and the points of inflection. Now I have the graph of x cubed minus x squared minus 2x plus 3 here. X cubed minus x squared minus 3x plus 3. So that's x cubed minus x squared minus 2x plus 3 as f of x. Now, the first derivative is the gradient function. Let's concentrate on this here. What the first derivative tells you is how far y moves, how far y moves as x moves along the tangent, and also whether it moves up or down. If you consider the function it is f of x equal. Alright, let's consider the function f of x equals x cubed minus x squared minus 2x plus 3. Then f prime of x equals 3x squared minus 2x minus 2. Alright? If I choose a point here, let's zoom out and see where we are here. Say -1. I choose -1 and make x equal -1. Then I have 3. Oh no. Yeah. This is going to be 3 times -1 squared minus 2 by -1 minus 2. That will be -1 squared is 1. 3 plus 2 minus 2 is 3. This is a positive, showing that the gradient, the tangent has a positive gradient. If we choose a point here, say we choose 0. Alright, say 0.1. 0.1 is where? About here. Then the gradient function is 3 times 0.1 squared, 3 times 0.1 squared, minus 2 times 0.1 minus 2. 0.1 squared. Alright, let's use our calculator and just get this out of the way. So, in that case, what we have is 3 by 0.1 squared, 3 times 0.1 squared, minus 2 times 0.1 minus 2 equals negative 2.17. So we get a negative 2.17. Now, the fact that we get a negative value indicates that if you should draw a tangent to the curve at this point, it will be negative. It will have a negative gradient. Let me try to draw it. No, it's not supposed to cut through the curve. It's supposed to just touch the curve. Want it to kind of look as if it just touches the curve. Alright, say that is our tangent. It has a negative gradient. Alright, so you have that. Now, where you have this tangent, when x move, say 1 unit, and if y moves 3 units, the gradient is 3. At this point now, if when x move 1 unit, y moves half a unit, then the gradient is change in y over change in x, half over 1. So the first derivative is telling us how far y moves with each movement of x, and whether y moves up or down. In this case, x moves from left to right, y is moving up. In this case, as x moves from left to right, y is moving down. Alright? So that's the first derivative. Now what about the second derivative? Let's erase these things. We have the first derivative here. The second derivative is f double prime of x would be 3266x minus 2. That's the second derivative. Right? Now, the second derivative is telling you how much the first derivative is changing. In other words, while the first derivative tells you how much y moves as x moves, which we call the gradient, the second derivative tells you how the change in the movement of x and y is changing. In other words, how the gradient is changing. So let's look at that. Let's erase these things for a while. Now, if we should find the gradient, or if we should substitute the value of x, or say -1, into the second derivative, what we would have is 6 by -1, -6 minus 2, which is -8. Right? If we should substitute a value here, say 0.1 into it, what you would have is 6 by 0.1, it is 0.6 minus 2, which is, this would be negative what now? 0.6 minus 2, -1.4, I think it is. You see, it's still negative. Now, if we should substitute 0.5 into it, which is right here, 6 times 0.5, 6 times half is 3 minus 2, which is 1. Positive. So we have a positive here, and at 0.1 a negative. Now, the significance of that is this. We have the tangent here. The first derivative tells you the slope, how high the slope is and in what direction. However, the movement in this first derivative is the movement of x and y only. In the second derivative, the tangent moves. So if we have another tangent here, we are looking at the difference between the first tangent and the second tangent, and the direction that the gradient of the tangent is moving. So it's like speed and acceleration, if you're familiar with that in physics. Speed is telling you how the rate of change from here to here, the rate of change of distance with time, right? Distance over time, speed is distance over time. Acceleration now is telling you the rate at which the distance over time is changing, right? Which is distance over time over time. The rate at which the speed or the velocity is changing. The speed is one change, and the acceleration is the change of that change. Here, the first derivative is a change in x and y. The second derivative is how the change in x and y changes. So is it right? A change of a change. Now you got negative values right along here, and then at some point it changed to positive. Now what's going on here is this. Let me, if I can get a tangent. All right, I want a tangent to the curve. So tangent, I want a tangent to the curve, right? Okay, this is my tangent to the curve. Let me make some adjustment to my tangent here. Let me make my tangent in blue color and make it thicker than it is here. Now, if I move the tangent, I don't want to see the trace. I don't want to, it's showing me the trace. Let me turn it off. If I slide along the curve, you see the front of the right hand side of the tangent is swinging downwards and the back is swinging upwards. The left is swinging upwards. I move my tangent further and the right hand side is still swinging down. It swings down and down. At some point it stops swinging, and then the right hand side start to swing upwards now. So the direction of swing changes, right? The direction of the swing actually changes. So at what point does it go down, the front of it, this right hand side go down and then up? We're going to find that out, but what this is saying, that in the second derivative, the second derivative is showing that this point would be a maximum point if there's a negative value at this point. Meaning, what that means, negative value means, is that the gradient of the tangent is dropping. It's positive. It's still positive here, but it's less so. It's less positive. The gradient is falling and falling until it becomes zero at some point, and it becomes negative and more negative. So the gradient is falling. So you have a maximum point. That's why when you find the stationary point here and the value of x is substituted, you get a negative. It means there's a maximum point. Now, at this point, you can see the gradient of the tangent is rising. It's getting more and more. It's negative, but it's less and less negative. It's becoming closer and closer to be positive. So it's increasing. When you substitute the value for this stationary point and you get a positive, it means there's a minimum point, because the gradient is increasing. It's rising up and up and up and up. All right? Now, as you saw, the gradient was swinging. The right hand side swinging down, slower and slower. Then it starts to swing up. Now, the second derivative is telling you the rate of swing. Now, if you want to find the rate at which the swinging stops and changes direction, at no swing, that means when you have the gradient of the line stop becoming negative and become positive, or changes from positive to negative, is where the second derivative is where the second derivative equals 0. This is 6x minus 2 equals 0. Equate this to 0. And then you find out what value of x this occurs. So 6x minus 2 equals 0, 6x equals 2, x equals 2 over 6, x equals 1/3. So when x is 1/3, that is the point where the swinging stops. Let me see if I can locate 1/3 more accurately. Let's get the curve upwards. 1/3, 0.3 is about here. Somewhere about there. Alright, let me mark where it would be. Somewhere about here. So, if you follow the tangent, right, and the swing, it goes more and more negative, negative, negative. It stops swinging, and then it starts to swing upwards now. The right hand side starts to swing upwards now, so the swing becomes positive. It changes from negative to positive at this point. It's called the point of inflection, right? And in this case, it is 1/3. So, there you have it. The first derivative tells you the movement of y with each movement of x, and whether it is up or down, positive or negative. The second derivative tells you the change in that movement of x and y. So while the first derivative tells you the gradient of the curve, the second derivative tells you how the gradient is changing on the curve. Alright? So that's it for this video. I will see you in the next video.